Today, we'll be talking with a robotics expert who will review videos of 10 robots from different companies. He'll give us his expert analysis, pointing out which bots are ahead and which ones, while impressive as a demo, don't have the skills that TeslaBot has. Very recently, Tesla showed off a video of the latest TeslaBot capabilities, and boy, did it really impress many people. The bot can now walk, it can navigate its environment, grab items, use tools, and more importantly, use its vision AI to navigate, move on its own, and take action all by itself. But so many others keep pointing out that Tesla is not the only company making bots. So today, we'll be looking at Apptronic, Agility, Figure, Sanctuary, Giant AI, Honda Asimo, Boston Dynamics, Romella, and OpenAI's 1X. Which one is the best? Well, let's see where you stand at the end of this video. Dr. Scott Walter is a robotics expert who has co founded two robot companies in the past. I've had him on several times now, reviewing a variety of topics about the Tesla bot. Now it's time for us to review the other robots being built. Welcome, Scott. Thank you for joining me again.
Herbert, thanks for having me back. It's a pleasure to be here.
All right, let's get brighter. Okay, so Scott, the first question I want to ask is as we look at all these videos, we're going to look at 10 different videos of 10 different bots,
Yes.
and we're going to get your reaction to it. What are the things we should be looking out for? How do we compare these bots with each other?
Okay. So I think the first thing is we want to remind everyone out there this is not an exhaustive list. Okay. Even though we're looking at 10, there's probably still some others out there. And the reason we're going through this is these are the ones that we've noticed that have popped up that a lot of people are talking about. And if we missed one, let us know and we'll gladly take a look at it. The idea of this is really to, kind of compare and contrast the different designs and to get an idea the problem is they're trying to solve, how they've attempted to solve it, and what some of those design choices were. It's not about throwing shade on anyone or criticizing them or anything else, because I have a deep amount of respect and admiration for all these groups and what they're trying to do. Humanoid robotics is a difficult problem, and it's nice to see all these different teams, and they are all trying to solve it a little bit differently. So we're going to look at things of like, what areas are they focusing in on more? Are they trying to make sure it's easy to program? Is it mobile? Does it have dexterity? How many degrees of freedom? Is it something that's going to be, more in a factory environment? Is it something that's meant to be outside? Is it going to have a lot of lifting capacity or not? What's the battery life? All these different things. And these are all choices that are kind of going on whatever the use case is. So we want to kind of look at it from that standpoint and see what we can kind of learn and ask ourselves these questions like, why are they doing that? Why is it important? How they're going about and teaching it, and what are the technological breakthroughs that we can expect to see as we go along?
Okay, good. So let's show this slide here. You asked me to do this. This is from a company called Sanctuary. They had a blog post,
Yes,
and it said how to create a humanoid general robot. And this image here, there's their robot, which we're looking at, Sanctuary's robot,
yes.
and it's got a brain, it's got a walking person icon, and a finger moving.
Okay, so the point of this, and first of all, if you haven't heard of Sanctuary AI, you're not alone. They were kind of in stealth mode for a while and made a press release on the same day as the Tesla shareholder meeting. So they kind of get a little bit overshadowed.
Mm.
Had there not been some announcements from the Tesla bot, people probably would have been talking a little bit more about this. So um, they've got some interesting blog posts in there to talk about their design philosophy and what they're going to do. And the reason why I like this is it kind of encapsulates the problem of solving the humanoid robot. And one is that you need to solve all three of those problems. And a lot of the different companies out there are solving the problem coming from different corners. No one's really solved all of them at first. So if you look down at the left corner where like the hands and the senses, I basically think of it more of like you've got to have good dexterous hands. You want to have hands that work and be able to solve from that standpoint. And it seems like Sanctuary has been putting a lot of focus on getting the hands. It's very, very important to them. We're going to see that there's another company out there, Agility, that I would say has really solved the walking problem. And we know Romela has been working on that, Asimo, but a lot of the others were really focusing on building the humanoid robot literally from the ground up, looking at the problem from that standpoint. And then at the very top, you've got the brains. And it's mechanically, the other things are very nice. You can solve those things, but without the brains, it's really hard to make it fully functioning. And of course, that's more or less where Tesla has come from because they already have this super AI computer that can solve a lot of problems, and they're realizing, wow, maybe we can actually use this to solve the overall humanoid problem. And now they're trying to figure out, how do we solve the problem of the hands, the problems of the walking. And so all of them are trying to close the loop on that triangle to be able to come up with a fully functional robot, because you can make something that looks like it moves like a human, but if you can't teach it, it's really nothing more than a mechanical apparatus that's able to play back some of the things you did, but not make its own decisions on what the task should be and how to solve a different task. So I thought that was a pretty good starting point to, when we do the compare and contrast, to ask the question, okay, what are they trying to solve, and how well have they solved that, and what are going to be the issues they're going to have trying to solve the rest of it.
Yeah. I noticed that under human like intelligence, it says under AI or teleoperation. So I'm sure
Operation.
we're going to see this, whereas under AI means it's just thinking on its own. It's got its own
Hmm.
brain, making decisions, visualizing things, doing something, seeing it, and making decisions on it.
Yes,
Teleoperation is when a human operator is using virtual glasses and then the ability to control the bot as if you're inside the bot, making the bot move. So
exactly,
I just want to point that out.
exactly,
Okay.
right.
Different companies
And,
have
and
different
it could
strategies.
and it could be for a couple of reasons. One is that they're using it to train the AI in the first place. And the other might be just to actually get the robot to work, because it doesn't know how to do the particular task. And so you're going to go in and do it and check out the dexterity of it. Sort of like if you think about what Waymo and Cruise and a lot of robotaxis is, they would like the cars to drive around, but every now and then they're going to get stuck. When you get stuck, someone's going to be able to
Yeah.
come in and get and move it around. And so the teleoperation would be able to do that.
Okay. Good. So let's go take a look at the first one here, which is Sanctuary. This is their bot.
And this is being done telerobotically, I believe. So
Okay, if you could just grab that other end there and just, yeah, cinch it down. So it's
Perfect.
locked in.
Nice. I didn't realize that that was telerobotically. This is
yes.
another
Movements and
video from
sensors feel
Sanctuary.
like one. Here you can see the same task being performed from 3 different points of view. On the left, we have the pilot operating the rig. In the middle, we can see what the pilot is viewing through the robot's camera systems. And on the right is the robot as it's being controlled by the pilot. Teleoperation or pilot mode is a key part of Sanctuary AI's initiative to help everyone work more safely, efficiently, and sustainably, and will create almost endless opportunities for work to be performed remotely.
So can I pause there? Is
Mhm.
Sanctuary just 100% teleoperation where a human is actually controlling it, or are they teaching it?
They're teaching. They're teaching it. So
Okay.
they're working on an AI system they call Carbon, which will control it. And so right now, I believe they're using the teleoperation to help do the training on that and to verify that the robot can actually do these tasks. So they have put. My understanding is that they've been around since 2018, and they've just announced their sixth version. So their sixth generation. What we're looking at there was their fifth generation. So the sixth generation has just been announced, and the fifth generation they actually had in a Canadian Tire doing operations around there just to kind of see what the robot could do. And I assume most of them were probably telerobotic, but they do have a video showing a lot of the different tasks they can do. Now, remember in that triangle, they were showing the different approaches that they're taking, that you would take to do it. And they focus a lot on the hands. So will be interesting when we look at the sixth generation, and even we can see it the fifth generation, their hand is more advanced than the Optimus hand. So they're really trying to get a lot more dexterity out of that thing. The rest of the arms and some of the kinematics is very similar to some of the other robots, but they have a lot of mobility in the torso and in the neck. So when we look at that, that's something we're going to notice. So Optimus has no movement in the neck. It's completely like this. Some bots you might be able to have like maybe 1 degree of freedom this way. Sanctuary, they have a full 3 degrees of freedom in the neck and in the torso, which you're going to see. And they've got what I think might be in the fifth generation, it looks like maybe a 6 axis arm. In the seventh generation, they might be going to a 7 degree of freedom arm out there. So, from the standpoint of the hands, Optimus made a couple design decisions. And that is, remember, they fused the tips of the fingers into one linkage mechanism right there. And they made what is the proximal phalange down here a little bit longer. So you get kind of rid of a knuckle with Optimus. And you'll see there's some other robots that do this, make the same decision. Sanctuary decided, no, we're going to make it just like a human hand. However, similar to Optimus, they made all of the fingers the same length. but they made an offset down here in the palm so that they don't go straight across. So you're going to kind of notice that in there. And they have more degrees of freedom. They say that they have 20 degrees of freedom in their hands. And pretty much what that means in the degrees of freedom is they've got all the knuckles here, so you're able to do that. And they're using, I think, one actuator just to be able to do that. But then it appears they have another actuator that allows them to do this kind of motion. So they're going to be able to spread the fingers apart, something Optimus cannot do. So they've actually added an extra degree of freedom there. And then the same thing with the thumb. So they have a total of 20 degrees of freedom, but we have to be careful when we say 20 degrees of freedom. It doesn't mean 20 degrees of control. There's basically 10 degrees of control, because what happens is that as you move this finger, everything kind of bends around these different pivots. So it's the same thing that Optimus has. Optimus has, I think, in each hand is basically 6 actuators, but 11 degrees of freedom. Sanctuary has probably got 10 and 20 degrees of freedom per hand. And they have
Okay.
way more degrees of
Yeah.
freedom in the body itself, which we'll be able to see it when we look at a couple of the other videos. Yeah.
I've got
So
a
when you
couple
look
more
at there,
videos.
yes.
Hold on. Yeah,
So
this one.
the hands seem to be, yes, that one there. So when you look at the neck area, you're going to see a lot of movement in the neck. And of course, the hand, if you just pause the hand for a second there, you'll see it looks like they have that motion on the wrist like this that I don't think they had in their 5th generation. So
Mm.
now I think they've added one more, which we refer to as like the yaw motion on the wrist. So they have full degrees of freedom. The fingers you'll see are a little bit more, the slight offsets there in the fingers. So they're getting ready to have an AI control system. I don't know how advanced it is, but a lot of head motion there. And so the hands are trying to have as much dexterity as possible. And you will see that they down at the torso, down the belly area, they have 3 degrees of freedom, just like they have one up in the neck. So I think the total number of servos might be something like about 52 compared to Optimus, which is 40, and maybe a total of 60 degrees of freedom total when you compare those. So they have more mobility. Part of what I think they put in the head is because of the teleoperation, they want to make sure that when the human's head moves like this, the robot's head does that as well. Because we saw that with Optimus, when the human was doing the teleoperation, the human looked down like this, but Optimus, because of the way the body was, it was like this, even though the humans had it head over that way. So what that means is that you have a better mapping between the teleoperator and what you can actually do in Sanctuary. Now, and so that robot they're coming up with is called Phoenix. Now, the one thing to be careful here is that in all those videos I saw, I never saw the robot walk.
Mhm. Yeah.
And you can see from the latest generation, they plan on walking. They haven't shown it walking yet. If you look closely at the 5th generation, it is actually on a mobile cart. So
Yeah.
it's really just the upper body torso, but it is on what appears to be a mobile platform. So they're doing a lot of things around there. How mobile it is, I don't know. So that also brings in another area of discussion we can have regarding what are the use cases? Because everyone keeps on saying, like, why do they need legs? Why don't they just have
Mhm.
wheels? Do they even need to have wheels and all that? And it's just like, it's the use case. And there is no one size fits all. It really depends upon the problem you're trying to solve. So if you're trying to solve a problem where a worker is just sitting at a line the whole day, I agree, you don't need legs. And you probably don't even need wheels. You may need a certain amount of deployability, the ability to move it from one station to another. The question is how easy or difficult should that be? So typically, out in the factory, we see all these robots out there that are bolted to the floor because it's been decided they only need to be there, and we'll keep them busy. We got plenty of stuff to just keep them busy, 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 busy. We don't need to go around there. Humans, a lot of times in these factories, are sitting there the whole time, and the only reason they have to walk is so they can go home, but then they come back in. So in theory, if that's a humanoid robot, you might say it can just be there permanently. But there are jobs where you just do it for a little bit, and then you need it somewhere else. And then you're done there and you need it somewhere else. So you need to have a certain amount of deployability. And that deployability might be that you just have a torso that you put on a cart. And a human just pushes that cart around to where it needs to be, locks it down in place, and then comes back a few hours later when it's needed somewhere else. So that might be one way. The other might be that that cart has a certain amount of ability built into it that the robot can control. And when it's needed to go somewhere, it just like, oh, automatically gets itself over there. The question is it worth the cost to do that? And the other, of course, you can give it wheels. And we're going to see a couple with wheels later on. But Boston Dynamics had a version called Handle that had the wheels. And the way to think of a Handle with the wheels had 2 wheels, and it was really fast, and they were able to do the balancing. It was absolutely great. But it was like a juggler on a unicycle. And if you ever seen a juggler in a unicycle, you know he's constantly doing this with the wheels to try to, whenever he's moving around, to keep his balance going. And that was the problem that you were having with Handle, is that whenever it went to grab a box, its wheels were trying to do everything to make sure it wasn't falling over, and it just didn't
Mhm.
have the stability. And Boston Dynamics learned from that, and they now have the stretch robot, in which they have this big mobile platform, not with two wheels, but with four smaller wheels that are really stable with a battery packed around there, and it's able to deploy itself. It kind of moves itself over to where the job is, which is unpacking boxes, and it will sit there for a while and do everything. And if it has to move up a little bit more, it'll go ahead and do that and do that. So it's kind of semi-fixed, but it has enough mobility. And it's one of those use cases that it makes sense that the robot is able to control itself as opposed to a human.
Mhm.
But then there are other operations where mobility is part of the activity that you're doing constantly. We see that on the factory floor in automotive factories, where the operator has to walk a few steps, but they still have to walk a few steps. They just can't reach way over here and reach way over there and stay in one place. They've got to have that mobility. And that's why you need to have a robot that's then mobile. And you're thinking, well, does it make sense to put it on wheels and have it, the balancing problem? Or does it make more sense to have legs? And then there's those that you're going to put out in the wild. You're literally going to have them walking around out in the streets and everything else. And sometimes it's just easier to have legs so you can go upstairs and on difficult terrain and everything else to have that kind of mobility. So they're all making these design choices that absolutely make sense. And so right now, Sanctuary is working on the mobility problem. So you can see they've kind of solved the hand problem. They're working with the brains where they've got the teleoperation, but now they need to bring in the AI component, and they're going to start working on the walking component.
Yeah.
So that is
Well,
Sanctuary.
let's take a look. Let's look at the 60 for 60, the things that the Sanctuary can do. Then we've got 9 other bots to look at, so we've got to keep moving here.
Yes.
Let's go ahead and take a look
Yes.
at this.
Yes, this is interesting because they're showing the dexterity of the bot that they have. So again, we can see the fingers have a lot of motion in there that are able to do some very common tasks. Things like zippers are difficult, soldering, we know that. And it's hard to keep up with how many they're doing, 1 second to look at everything. But they are proving that they have the dexterity, which is really quite interesting. A lot of it, yes, they may be doing it telerobotically, but again, from that, you can get the training data that you need to be able to make sure it can start to do this autonomously.
Okay, wonderful.
Yeah.
Very interesting.
Tweezers, that
Nice.
was an interesting one. Yes. So
Okay.
you can see that
Nice.
they're moving along there. And the one thing is that everyone wants to know with these companies is what is are they going to be around? What's the survivability of them? They've been around since 2018. They're working on their 6th generation robot now. So they're iterating. So they actually have something out there. They've got real data, and these are their investors. A lot of the others, have some sort of seed funding that are coming in, but there are a couple of household names there, right? You recognize a few of those names?
Of course, yeah.
So, Bell Canada, Verizon, EDC is the Export Development Canada. And do you know Magna? Have you ever heard of
No.
Magna?
No.
Magna is the largest automotive OEM that you've never heard of.
Right.
They are a tier 1 supplier to almost all the automotive companies worldwide. They are a joint venture of a Canadian and Austrian company, and they build most of the lines. So they're the ones that go out and get the robots, design the cells, get the tooling, bring it in, program it. They do everything, and then they hand the keys over to the OEMs and say, go ahead and run your factory. In some cases, the OEMs will say, you run the factory for us and build the cars for us. Okay, so they know a lot about manufacturing. And just to give you an idea is that, that Rivian and Lucid are having a really hard time with getting their prototypes manufactured. And, there's other EV companies out there trying to do it, and one of them known as Fisker. And we've all been kind of like questions like, okay, they're going to have the same problem. Fisker said, Magna, build the cars for us.
Yeah.
They actually have a chance to survive because rather than Fisker trying to build the factory, they're going to someone that already knows how to build automotive factories, is already in kind of the EV space because there's like, oh, we're going to have to start supplying all these others. So they have that expertise. So when I saw Magna in this, I said, this is interesting. Is Magna in there because they know how to build things and they'll know how to build this robot? Or are they there because they're thinking, hey, this robot could be really useful in our factories?
Probably both.
Or it's for
Yeah,
both
probably
reasons.
both.
So that's why I point that out. And full disclosure, Magna is a client of ours. Okay?
Yeah,
So,
gotcha.
so I have worked with
Okay,
them in the past, but I do not own any stock in them or in Sanctuary AI. So I just want to bring that up full disclosure.
nice. Okay, that was full coverage of Sanctuary. Let's move on to the
Yes.
other examples. Here's a company called Apptronic. Let's take a look at their
Yes.
bots.
Okay. And they, I believe, are a spinoff from the University of Texas in Austin. And again, you can see they've got some mobility in the torso, standard kind of 7 degrees of freedom, same kind of shoulders that we're seeing in almost all the other robots. So very common kind of design on the arm. And the head has a little bit of mobility in it as well. And the hands, they're looking at the fingers. I haven't quite seen enough of a close up, but again, they're using teleoperation, and it looks like are they able to do the live long and prosper? I mean, that's the key. If you're able to do that, that means you're not just being able to do this with the motion of your fingers, you're able to do something like that. So it's maybe a bit more constrained than what we're seeing in actuary, but they still have, a fair amount of motion. And again, it's, very kind of standard in what you'd expect to see. So those fingers look rather intriguing to me. And definitely they have 7 degree of freedom arm with what he was being able to do with that kind of movement. Absolutely. So it's something I just saw recently. I haven't seen much more than this. So it looks like they're getting in that space. It's interesting. They're in Austin, who else happens to be in Austin? So I'm sure they're learning quite a lot of things about what that particular space is going to be. I don't know much more than what you've sort of seen there. It seems to be just a torso up. They don't have the walking part yet. They're
Yeah.
probably using teleoperation and really trying to figure out the mechanics. And again, it looks like they had a certain amount of dexterity in the hands, so they're probably approaching it from that problem, which a lot of robot companies need to.
Like say, you know, they look cool, but it's all teleoperation at this point. It'd be
Yes,
interesting to
it's
see how they're going to
teleoperation
get
at
the
this point.
AI part
Exactly.
of it, right? You need to have both the
Mhm.
manufacturing and the teleoperation. Okay, that's
Yes,
Apptronic.
yes,
Let's go to Agility, a company called Agility. Let's take a look at them.
In this
yes.
demo, Digit
This
is
is
given
really
scene
cool.
information about the
Mhm.
objects in its environment.
So
It
listen to
knows
this.
that there are several items on the floor with semantic information. Hey Digit, clean up this mess. When I walk on screen, I issue a voice command to Digit, which it recognizes based on hearing its name. At this point, Digit makes a prompt to an LLM that solves for what it can do to satisfy this voice command given its physical intelligence around how it can interact with the world. The prompt is specially constructed so that Digit can interpret the response of the LLM as a set of actions it can take in the world.
I mean, that's pretty interesting because it's a like that was a soft item, and these are harder
Yes,
items, and somehow able to
yes,
figure that out. Hey,
On
that's
the
pretty cool.
floor into the appropriate bins for
Let's
each
watch
item.
this.
yes.
This is so cool. Watch this.
Look at the hands.
Come on.
Okay, so
I'll keep playing it while you go and talk on it. Go ahead.
all right. So yeah, what we can do is that you'll probably notice that the legs are very interesting in this bot, and there were a lot of people very interested in this bot at ProMat because it was able to do it. So this is a spinoff from the University of Oregon, where there's a group there that solved the problem of walking first, and they wanted to know how you come up with a walking robot, and they came up with a very different leg design than people expected. Now it looks
Yeah.
an awful lot like a flamingo or an ostrich, the way it looks. And this robot is called Digit, and the reason why it's called Digit is it's basically the type of walking. You can classify different animals in the way they walk into plantigrades, which is what we are because we plant our feet, or digitigrades. And this is a digitigrade because it basically walks on its digits as opposed to the flat part of its feet. And now, what you are looking at there, what you think are its knees in the back, are actually its ankles. And if you look up, you'll see it has a small knee up in front. So basically, if you take the morphology of your leg bones and just change the lengths of them, you end up getting something like that. So it literally is walking on its toes. What you think are its feet are actually its toes. And then you have that what looks like the lower leg. That is actually the normal foot bone. And then you've got the ankle joint back there that goes up to the knee joint, and a very small femur that goes up to the hip. And that gives them a lot of interesting mobility for as far as balance and be able to get very down low to be able to pick up something. So they wanted to solve the problem of walking first and then figure out what kind of platform to put on top of it. And they didn't want to come up with a torso and an arm. They wanted to see, can we come up with a solution that isn't that? And the more and more they worked on it, the more and more they realized that there's a reason why we have this form the way it is. And they wanted to, they also at first didn't want the head to look like a head. They were trying to figure out how can we do something without having a head? And they had something on it that was a bit too creepy. And then they put a different type of head on it, and they put the right kind of head on it because it's not one of those uncanny valley heads. And it's not one of those kind of Terminator heads. Like, Optimus looks a little bit cold blooded when you look at it. It just, I'm not sure. This one, it looks friendly. And that's one of the dangers they have is that small children are going to come up and want to hug it. And they don't want that to happen. So you want to keep it back a little bit. But they've been solving the problem by trying to take a fresh look and realizing we need this. But they've been trying to keep the degrees of freedom down. So their torso doesn't have a whole lot of motion. Actually, they don't have any movement in the torso. They've got the arms, and they've gone through a couple generations of arms. The first generation of arm was a 5-degree freedom arm with actually almost no wrist, and you would put like almost these little rubber balls, and you had almost like tennis balls on it to allow you to grab totes and move them around. Their next generation, and I had gone in, I really liked the kinematics they had come up with it, and they completely threw me off because they came up with a new one where they completely changed the shoulder, and it's now kind of a standard shoulder. It's a standard 7-degree of freedom arm. And they don't have any fingers, they don't have a hand, but they do have a palm. So that's why I said, look at the hand, look at the hand. So what they have is they've got this, and that's good enough for the application they have. So it's like, okay, we don't have to worry about the hands, but there's a lot of things we can do with that in different workspaces that are fine. So we're not going to do sewing, we're not going to do zipper or anything like that yet, but there's a lot of useful work we can do in factory simulation or factory situations that work out well. And they have a very low degree of freedom count. I think they're down to like 24 degrees of freedom. Optimus is 28 degrees of freedom and what they call structural without the fingers. Okay, so comparing that 28 to 24, so they're a little bit lower because they took some of it out of the torso. They don't have any movement in the head either. And because they don't have the fingers, they've been able to reduce that. So that could give you some advantages in battery life. And very interesting balance, very interesting way that they walk. And there are a lot of videos. When you go to the Agility Robotics website, you will see a lot of videos of it walking out in the wild, delivering boxes to front doors. It's very interesting that it can pack itself up very neatly, come out, walking in the park, going up different terrain on grass and everything else. So, and it looks very confident when it walks. It doesn't walk really slowly. I think it's supposed to go maybe 3 to 5 miles an hour, something like that. However, the legs that this is based on, there's a bot out there called Cassie, and Cassie currently has the world record for the fastest bipedal robot. And it did the 100 meters in about 22 seconds, I think, something like that, 22 or 24 seconds, somewhere around there. So it's not like an Olympic gold medalist, it's like 9 seconds, somewhere around there. So it's about half as fast, but still is pretty fast. And I think it's close to 10 miles per hour and what to do, something like 9.5, 10 miles per hour. So that shows you that they know how to walk. So in that triangle, they solved the walking problem. And you see they're getting up in the AI there. They figured, hey, let's get the LLM, let's talk to this thing, and let's have it figure out what it's going to do. So they are working on that problem as well to make sure it's really autonomous. You just tell it what to do.
Yeah.
The other thing you can say about them, they've been around a bit, is you'll see videos out there of what to do when you get your digit robot. And these videos are like a year or two old for the customers. Like, oh, it just arrived. You open up the box, it's in there. It's mostly assembled. There's a few things you have to take out. Oh, you put this thing. Here's how you boot it up. Here's how you start it. So they're already selling these things. They already have it in some customer hands, and you can see they've got quite a fleet of them. There were a lot there, and they were at the ProMat show, not because they wanted to talk about what's coming, but it's like, we've got a product that we'd like to sell.
Nice.
So
Okay,
they're
that's
already
pretty
getting
cool.
them out there in the field. Yes.
Yeah. I actually have that video that you're talking about with Cassie, so I'm going to play that.
Yes, exactly. Reminds me a little bit of the walkers in Star Wars.
Mhm.
And the tricky thing was to be able to make the run without falling down. And I think there are a lot of them where that might happen. Uh, and that's pretty good. I mean, so it operates quite well. And then they figured out, okay, what do we do to put everything else on top of this? And
Yeah. So
so they've gone through a couple of generations of that already. So I see them as a very good design that's going to solve a lot of problems very soon.
yeah. All right. So let's review quickly because I thought this is very interesting what we've seen here so far. Right. So first we saw Sanctuary, and I'm not going to play
Yes,
the video. I'm just going to show you what it
and
reminds me
test
what it
the
looks like.
capabilities of the
right.
system
So
on how to
Sanctuary
perform a
is this
task.
beautiful robot, but it doesn't have the torso at this point, and it's teleoperated at this point. But they
So
are
yes,
saying
yes,
they are working on the feet, on the human
on the
bipedal
leg. So
walking,
it
and they are
doesn't
working
have the
on the AI,
legs.
but they don't have it yet. But really cool
Correct.
bot. Look at it, fingers. Looks like pretty awesome. Then we
Yes.
saw Apptronics, and Apptronics only has again no torso, and
Yeah.
kind of
Or,
cool,
yeah,
but
yep.
again
So they got
not
yep.
yeah.
Mhm.
Then we
So
saw
they yeah. So
agility
Digit
digit.
started out knowing that there are different types of
Now
items and
digit
different.
is super cool because it actually has an AI, it has vision, and it can recognize objects like these objects at the beginning here. It tracked it, grabbed it, and moved it. So, and then the only thing is they don't actually have fingers and they have this modified feet, but it looks like it's walking, right?
yes,
Yeah,
yes. And you can see it can do things like it can pick up boxes very well with that hand.
yeah.
And there are different attachments you can put on there to make it maybe easier to grab certain objects. And you see how low it can go down. So it's very easy for it
Mhm.
to pick it up. And it can apply a lot of force. So it's an empty box. And so this can be used for parcel delivery. So they're looking at
Mhm.
examples that you could have autonomous driving vehicles deliver packages, and then this will be the last foot delivery. So it gets out, picks up the box, walks it right up to your door, and drops it off there. So there's a variety of things you can do that you do not need to have the digits on your fingers. Okay, so this is kind of funny. The robot's called digit, but the one thing it's missing are kind of the digits we're used to on the fingers, but it's got
Yeah.
everything else. So it doesn't have the hands, but it's able to do a lot of useful tasks. And many of these tasks are those totes that you see over there. That's very common in many factories of someone having to go grab the right tote off of a shelf and just go ahead and put it in the conveyor.
Mhm.
You got workers
And
just
well,
doing that. So
what's
they could
impressive,
be doing it with mittens.
yeah, what's impressive is that it's got vision and it's got the ability
Mhm.
to identify objects and then grab them and move them. Whether or not it knows, if they had to code it on how to take something and move it into the box, maybe they had, but it knew how to do that. That's the really cool part, right?
Yes, yes, and the fact that
Okay.
it walks so confidently, and it seems to be able to maintain its balance even when it has a load, just is quite interesting and impressive.
We have one more company here. It's called Figure. That doesn't look like they have much. It's just a promo video. Let's take a look at that.
Yes, look at the fingers. They've done the same thing that Optimus has done. That they've fused two of the finger bones together. We can't see much about how the shoulder is designed, or the elbow, or anything else about the arm. We don't know if it can walk. There was a quick glimpse at what might be a leg design, but we can't really tell very much.
Yeah. This is just a teaser. So looks cool.
Right. And this was
Oh, yeah.
mostly a teaser, I think, for investors. So they just finished their first funding round, I think. They got maybe $70 million to start on something. But they're hoping to have something ready by the end of the year. So we'll see. I mean, I'm not sure how far along they are on the design and how far they are actually into getting it ready. But there's a lot of elements you have to solve there. Obviously the hands, the walking, and the AI. So we don't know much more than that, except there's a lot of buzz about them, and there's a lot of people interested in investing in the company based on whatever they've been able to show. But from what I've been able to see, we don't know much more than that.
Okay, wonderful, Scott. Thank you. So we've covered quite a number of bots already. We got four more bots to go through. Let's get started. Let's do the next one is Giant AI. So let's take a look what they've got. You want to speak to that?
Yeah. So as we can see here, Giant AI, we were first introduced to them almost a year ago when Robert Scoble got sort of the first inside scoop. And they were showing before the TeslaBot was released the kind of humanoid robot they're able to come up with. Now, this is from the torso up. It isn't walking, but the idea is, again, if you do not need mobility and you're doing something which is a fixed task, can you come up with a humanoid form which has the dexterity to be able to do it? So they've been doing a lot of teleoperation to teach this and are using, I believe, nerfs to be able to understand the environment, to scan it, and to figure out what it has to do to be able to do the picking and placing and selection of different objects. Now, the approaches they've taken here are a little bit different. I believe that's only a 6-degree freedom arm, not a 7. They have also some interesting fingers there, which are all tendon controlled, and the servos are all down in the base, in the torso. So there are actually no motors out there. So everything is cable driven, which is extremely interesting. So mechanically, they took a very different approach, but it's a challenge to be able to get the finesse and the control that you want. And just looking at that, I find it rather amazing that they've been able to get that kind of dexterity with the servos really down there at the base. And they're not trying to solve the walking problem. They are trying to see if they can come up with a bot which has enough dexterity in the arms to be able to do real world tasks that would be in the factory. I believe they were really trying to focus on some of the small assembly time of lines where you have a lot of workers who are just sitting there the whole day working in one particular workstation doing the same operation again and again and again. And the trick is just getting those hands, and they've done everything I think with tendon control and the fingers right through the arms, and everything else is tendon control. That is a design challenge and control challenge to be able to do that, because as you pull on one cable, it affects everything else. So
Yeah.
how you get the compliance in there and account for that, I'm not quite sure. But they managed to do something where it looks pretty fluid, and I know they've used a lot of operation to help train the bot. And from the name Giant AI, they've got some sort of AI group that is trying to solve the brains of it. So again, they've
Yeah.
got 2 parts of that triangle.
So it's quite interesting the different kinds of bots we're looking at. This one here decided let's not do the bipedal walking. Let's just do torso and up.
Yes.
But it is able to recognize, it's able to grab things and
Mhm.
move. It's just restricted by torso and up. And they were saying
Right.
that the CEO was saying we think that there's tremendous amount of jobs that can be done, like you said earlier when you set that up.
Yeah, yeah, and I
Okay.
think there's some
On
of the
the other
problems you
side,
solve by doing that. One, first
yeah,
you don't worry about walking because you're saying, look, there's a lot of factories out there where you don't need to walk. It's just going to be there. You don't have to worry about the battery problem, right?
yeah,
So the torso doesn't have to be batteries. It can be something else, and that means you just plug it in. So you put it over there, you plug it in, and all motors are down low. So now you're not carrying the motors anymore, having to design special motors. So they had all the servos down there, and really is cables going through everything. Everything is tendon control, and that is just remarkable. The shoulder, the elbow, the wrist, the fingers, all that they done with cables, and it's intriguing. And it's not. I wouldn't make that design choice,
mm,
but I'm glad someone did, because I would, it's like I don't think you can do that. It's crazy. It's good someone's exploring that, because maybe that is a solution, and we'll find out.
yeah. We'll find out. But the reason why they did it is because the next organization we're going to look at is Romella, which is led by
Yes.
Dr. Dennis Hong at UCLA, very well known robotics expert, the professor. They've been doing this for decades, over a decade at least, and they have 7 different robots. And only one of them was humanoid like that walked in bipedal walking. And he
Mhm.
was interviewed and
Right.
he said that it's very, very, very difficult. It's one of the most difficult thing. And so we're kind of taking it for granted. We'll look at Boston Dynamics soon. We'll see Honda Asimo. We've seen demos of bots walking, but he said it's so hard. So the one bot that they did work on called Artemis is their one bot that is able to do bipedal walking. Let's take a look at that one.
So this is very interesting, because the problem with bipedalism is not falling over when suddenly you get a shock, something unexpected. So again, their control system is able to react very quickly, and they want to make sure. Look, that's very good. So walking and running is basically a controlled fall, and you can kind of see that right there. That
Yeah.
when something happens, it is starting to fall over. So it's on an uneven surface that's not expected to be on. It loses its balance, and it doesn't attempt to recover its balance right away. It says, okay, I'm going to continue to fall, but I'm going to keep trying to break my fall. until eventually I can get my balance back. And that's what we do as humans. We're not quite aware of that, but when we are falling over, we don't catch your fall right away. It might take 2 or 3 steps to do it. So the control system's got to figure out what's going on. You got to get the balance, and they want to make this a robot that's going to be in a competition playing soccer, which means you have to expect to be falling down all the time, or to be taking blows or getting hit by a ball or another bot. And of course, that's going to be very useful when you start talking about useful applications, such as carrying things in a factory, different loads. How do you recover from that? So Dennis Hong has worked on many different types of walking robots, with four-legged and maybe more legs than that. He was first, I believe, at Virginia Tech before he came to UCLA, and some of the designs that he was starting on over there have actually made it into TeslaBot as the knee design. So a lot of the work that they did there, and I believe some of his students have also ended up at TeslaBot. So that's one of the reasons to always keep Romella on the radar. What they might be up to, you never know, is going to probably end up making it somewhere else eventually. So again, they are a research lab. Their charter is not to create humanoid robots that will be for sale, but certainly to do a lot of the fundamental research in what would be needed that others are going to be able to build on top of. So I think it's keep your eye out for what Romella is up to.
Nice. Okay. All right. So there's a bot that everybody's been looking at for a decade, it feels like. And we thought that
Mhm.
robots were here already. It's called Honda Asimo, but now they're not
Yes.
even in production, right? But and when you look at this video of the Honda Asimo, it's very impressive. And this was like 5 years ago, whatever the year is. Let's go take a look at this.
A
Yes. I think
remarkable technological
2018
achievement.
is the last year of it.
I'm going to turn off the music, but do you want to take a look
It
at
was
this thing?
about
I mean,
30
this is
years of development. They were one of the first walking robots. So some of the early Asimov robots were just legs. They were just trying to solve that problem. And because they were doing it 30 years ago, the robot literally had to carry these very big, bulky computers to figure out how to walk around. So that was a challenge, not just to have the computers and control system small enough, but the legs had to be powerful enough and have enough balance capability to be able to carry those control systems around. Now that they're smaller, of course, it makes it a lot easier. But they were working not just on walking, but being able to walk upstairs, and then, of course, come up with the rest of the humanoid form. And it was able to do quite a lot of things. Uh, at that time, you didn't have the AI, so it was a lot of heuristic programming. And it was a nice demo model, but no one was able to really find a good use case for it, except that it was very entertaining and was groundbreaking because it sort of showed the capabilities of what could be done. And it's a shame that Honda decided to pull the plug on the project. But yeah, a lot of people have found that, let's say, a lot of inspiration of what can be done. And I'm sure everyone that's in the humanoid robot area building these to say, yep, that was what sort of inspired me to want to continue in this field because we saw it could be done. And they probably said, aha, I bet this is the missing piece. This is all we have to do. So I want to go in and work on that piece.
yeah, it's very, very thought provoking of what's going on here. So first of all,
Mhm.
it could be just beautiful demo. Could be just a
Yes,
beautiful demo. Um,
yes, it is.
because if it was so easy to make, if it was doing what we saw, why would you give up on it? That's the odd part. And it's Honda. So Honda bought
Yes,
them
yes.
from Sony, and so they would have a factory just like Tesla's doing, and everybody's saying what they can do. But it probably didn't have a brain. Certainly not. Not well, it was too early in the early stages. This was not AI. It was probably very programmed, painstakingly programmed. So it was very impressive. I mean, that has blown me
Very
away.
impressive,
I
very
think a
impressive, and
lot.
they solved a lot of problems with it, a lot of
Yeah,
problems, no doubt
the
about it.
demos are very impressive. But there's something
Mhm.
fishy if they decide to drop it, the program, which is just shocking because they look like they were ahead. So
Mhm.
that's what the reason I bring this up is that a lot of people have this in their head. They go, "Oh, bots been solved a long time ago. I saw the Honda Asimo. I've seen it. These videos have been around for years." So they think it's easy to do the walking. They think it's easy with the hands. They think it's easy for it to recognize and do things, not realizing no, that's hard. And I think the other part that we haven't talked about yet is scalability of manufacturing. So while we've
Yes,
seen so many bots already, we're going to see Boston Dynamics, which is the one that everybody's waiting for. It's about the ability to create it in scale at a cheap way. So when we see these
yes.
bots, all the bots we've seen so far, They're great demos. They're onesie twosies, maybe 10, maybe 20, but that's about it. No one here has a factory that's going to create this in scale. And that's why we spend a little bit more time on Sanctuary, because they've got the investors and they might have
Mhm.
Magnum, which is
And
potentially
I'd say even agilities get the possibility because of low degrees of freedom. It looks like it's designed to be very safe around people, and we've seen lots of bots that they already have. So I think they're
mm,
scaling up and they're
maybe they
redesigning
might
it
do
to
it.
be able to do that. So they might be able to do it, but again, in Boston Dynamics is they build all these things as prototypes, and they have enough that they can make sure there's more than one atlas, because when they do these shots, we're going to see something. They needed a lot of them because they fell down a lot, and they were constantly getting broken and having to be repaired because they were doing very complex tricks that were just not easy to nail the first time. And so they had that, but they weren't really set up for mass production. And they've been talking about that now, that like if they can produce 1,000 bots a year, they will be very, very happy. But they don't come from a manufacturing background, and they are learning that right now, which means they have to learn how do we actually redesign everything to make it easier to be built. And that's where Tesla is coming from, is they're already thinking, how do we build the robot when they are building the prototypes, not let's come up with a prototype, then think about how building it. So that's a very different mindset that the companies need to have. So we're
Let's
ready
take a look
for
at Boston
Boston Dynamics.
Dynamics.
Yeah.
This is the one that everybody says is way ahead of Tesla. Let's take a look at the full 2-minute video. It's very impressive, and then we'll get your reaction to it.
Forgot my tools again. Such a show off.
Okay. So that's
Wow.
great. Now there's the companion video where they actually show the behind the scenes and how it was made. And I'm really happy they did that so we get an idea. So the first thing is it is scripted. It's not that the robot figured out how to do all those things itself. So they kind of came up with the script you're supposed to do. But still, you could see there was a lot of issues with the balance that the robot had to go through. A lot of that was very challenging, required a lot of power and to be able to do that, and certainly the backflip. And that required a lot of practice, and they broke a lot of bots. But you can see that whole thing was pretty much one take. So they were able to get it. They didn't have to do a bunch of cuts and splices together to have, well, we get the bot work for 30 seconds and this one fell over. But no, was able to get the whole thing, and they're getting there. And they're starting to build more and more AI kind of capability in there. So there are certain tasks that we know it wants to do something, and it's going to go over there, but it's not going to be a full replay. It's going to go over and realize, oh, this is not quite where I want. It will make those adjustments on the fly as necessary. So you can see it's got good dexterity, or the ability to go down, but it doesn't have a full set of hands yet. So it does have something to be able to lift up some of these things, but doesn't have the full fingers or anything like that to be able to do other tasks, because the application space for this is a little bit different, to be more outdoors. And um, eventually they're trying to look at these applications in the factory floor that you would be able to use this particular bot for, but it's really meant more for um, it was set up at DARPA to be kind of more like search and rescue kind of capabilities, to be able to go into an area that's a little bit dangerous and walk around and be able to investigate to see if everything is safe, or maybe grab something and pull it on out. So it's a research project, and they are trying to learn how to manufacture these things. So that's the next step, to make more and more of these things. So it's an interesting bot. Everyone sort of likes it because it was one of the first ones out there. They've been around 30 years working on this, and of course they have some other robots out there that are more couple that are starting to look more like traditional industrial robots. The stretch robot that I kind of talked about for being able to move boxes around, and then they have the little dog. I think it's called Spot. that's able to go around. That also they're selling, I think, close to 1,000 a year of those that go around factory floors and in plants to go up and actually read dials and gauges. So if you've ever been to like a refinery, there's all these pipes and rooms and everywhere else and stairs you have to go up around. And a lot of times someone has to go up there every now and then with a clipboard and check, oh, is pressure okay and temperature all right, go around. So these things can run around and do that instead. So
Yeah. Yeah.
yeah,
So let's do a roundup and compare it to TeslaBot, right?
yep,
So we've seen
okay,
all these bots. Some of them are very, very impressive. At the very beginning, you pointed out that it needs to have three items, right? The brain to be able to make
right, yep,
decisions, or it's teleoperated. Some human is maneuvering it. Then you've got the fingers and the hands, the ability to walk, and then the senses, whether it's got vision, whether it's got feel, touch, all that kind of things, right? Now
yes.
we've seen a bunch of these bots. Some of them don't have torsos, some of them are teleoperated only, some of them don't have the hands, and all of them, as I pointed out, don't necessarily have the scalability factory to build these. And then you've got Boston Dynamics. Everybody believes that they are the top competitor. So first of all, let me ask you that. What makes you think that Tesla is ahead? Or am I putting words in your mouth? Who of all these
No, no,
bots that we've seen and others?
I think
Yeah.
it depends upon the use case. So within what Tesla wants to do is get them running in their factories, and so I think they're designing the right robot for that particular use case. We could see agility is probably in a pretty good case situation right now because they're already getting it out into customers in certain factory-like settings, but they don't have the dexterity to be able to do certain operations. But they can already take care of some of that. Sanctuary is just starting to ramp up there. They've already been out in the field to do some testing, but now they're getting ready for the next stage. And then we see there are some others that are starting to come. They're coming out with proposals or getting funding, but we have yet to actually see a working prototype to see what they're going to do. Now, as far as if you want to actually compare, let me ask you a question, Herbert. Which robot do you think is the shortest of all the robots you've looked at?
Well,
And
the
which do you
digit
think is
one
the
can
slowest?
bend, but then the giant A1 is only torso up.
Yeah, yeah. But if we look at the humanoid robots, they're both. I think Asimov is the shortest. Asimov
Oh yeah,
is, I think,
yes.
under 5 feet. But actually, how tall do you
Yeah.
think Atlas is?
Atlas, which one's Atlas? Boston Dynamics
The
look
Boston
pretty tall.
Dynamics, yeah,
I'd say 5'8", 6 feet. Mm-hmm.
4'11",
5'8". Four. They look tall.
4'11", 4'11",
Yeah.
yet 200 pounds. Okay, so 4'11",
Yeah.
200 pounds, a walking speed of 5.5 miles per hour, and a payload of about 25 pounds, and a
Wow.
runtime of 1 hour. And so it's hydraulically actuated and with the battery pack. And so at first they needed a lot of other power to do it, so it can only really run for 1 hour. And I believe it has maybe 28 degrees of freedom within those actuators. Which one do you think is the tallest of the robots that we saw, of the full humanoid robots?
Yeah, I don't remember it anymore. I'm getting confused.
It's actually digit. So so
Yeah,
so
because it can
digit's
stretch.
ability, because it looks like you can
Yeah,
really get up there. So it's
yeah.
5'9". Optimus is 5'8". The Sanctuary robot Phoenix is 5'7", and Figure has announced that they're 5'6". Okay. Now, as far as the weight, Digit's about 141 pounds. Figure, they're announcing it'll be 132. Optimus, the announced weight is 125. The first slides that they showed 2 years ago. My guesstimates, it's a little bit more right now. If I go down and add everything, I'm thinking it's maybe 130, 135, somewhere around there. The Phoenix robot from Sanctuary is listed as 155 pounds. The speed of all of them is like in the order of three or 2.5 to 5 miles an hour, something like that. So most of them need to be around three. That's about all you need. Actually, the walking speed in the factory, I think, only needs to be about 2.5 miles per hour. You don't really need to be three. So that's more than fast enough. The payload, the Digit is 35 pounds. Figure is announced 44. Optimus is 45, and Phoenix is 55 pounds. That's what they've announced. Now, as far as the runtime, so Atlas we know is 1. Digit is 1.5 to 3 hours, but they say
Is it? Hmm.
16 hours in a 24-hour day. So you can get 16 hours of operation in a 24-hour day. But depending upon how it's being used, if it's like more idle, anywhere from 1.5 to 3 hours between charges. Optimus is 8 hours. Figure has announced 5, but I mean, you can announce anything that you want. And then Phoenix, I don't have a number for that. And I'm not sure how they're doing it because clearly the first generation looks like it was plugged in, so it didn't have a battery pack. And looking at the Phoenix, that very flexible torso, I'm like, okay, where are the batteries in this thing? So I'm not sure how they're solving that problem and what the runtime is going to be. So we'll have to wait for them to make an announcement on that. But so, the one reason why I think Optimus is in a good position is first they have the AI, which is the brains. The brains has always been the problem. So as you can see, Asimov has been around a long time. I mean, I think what you're seeing there with Asimov was almost doing that 2000, 2010, something like that, just as 2018. So you already had that kind of dexterity. You could always make those kind of motions. So just go to Disney World. I mean, you'll see these animatronic figures that look very lifelike. And, you can almost be convinced that they're moving. They just don't have the brains. And that's what's sort of missing. So you need to have a good AI and the FSD and with Dojo and everything else that's in there. I think that's really what's going to separate Tesla is that they're at the top of the triangle. So you notice that triangle was kind of like a
Mhm.
pyramid, and the very top part is up there. So those other two, not to trivialize those are very complicated. They have to be done. The question is how well they have to be done. Do we have to be able to win the Olympic 100 meters? If we don't, then we don't need to have something that's really fast. We just need something that is stable enough. Boston Dynamics is very good at the stability. It's able to move pretty fast. Agility we see is very good there. Agility is working on the AI part. They don't have the hands. We can see they don't have the hands yet. Sanctuary clearly is got the hands. And also Giant AI has some pretty good hands. The others are working in that area. And there are some very interesting hand designs that we didn't have a chance to talk about. I don't know if we're going to that OpenAI had this freaky good hand that I don't know why it hasn't been put on any robot arm or in use yet that's able to do the Rubik's Cube. And this is a hand that has like the full dexterity of a human hand. It's got all the degrees of freedom. So you can see they put everything in there. They really made sure they could do it. And it's controlled by an AI to figure that out. And so they can just bounce that Rubik's Cube around and solve the problem. So they're understanding that. And so, at first they're going to drop it a few times and eventually it gets better and better. And they used a lot of simulation to figure out how to do this. So they're able to do the millions and millions of iterations that were needed to train it until they could get to the stage that when they gave it to the physical hand, it was able to do it and to learn what the real physics was going to be like. And it got better and better with the real physics. And as you can see, they could just start throwing everything at it and it still works its way through. And one of the things that they were shocked, it's a paper out there about this from OpenAI. They discovered some emergent properties that they didn't expect that it was able to sort of figure out on the manipulation of the Rubik's Cube. So it's a great hand. I'm just not sure why it hasn't shown up in any of the humanoid robot forms yet and what's going on, because that is one of the keys if you're getting that kind of dexterity. So depending upon your use case, agility is not going to be used in the house because if you need something to fold the laundry or to zipper up a jacket because it's going to be like a nanny bot, then agility is not going to be the one for you. If you're running a factory, it's going to be a pretty good robot to be able to do a lot of the tasks that you need to do. Sanctuary looks like, it might be there. It's got some of that dexterity. It's hard to tell about figure because we've just seen like the first images, but it doesn't quite have the degrees of freedom that you can see in Sanctuary. But the question is whether you need it, because it comes down to how important is that little motion in her fingers up there, or can we just sort of fuse it together and say that's good enough and just have this knuckle and that knuckle? I don't know, because Optimus is doing that. They're doing the same thing. So it's good enough for a lot of these factory environments.
Yeah.
Absolutely.
So, okay. That OpenAI is the company that's doing ChatGPT, which is a large language
Yes.
model. They decided not to get into robotics, but they did invest in other robotics companies. And then they showed that demo though. So they're definitely going to get into this. They're just
Yeah.
trying to figure out a way. But the point being that in order to be able to do neural networks, which is the brain to control the bots, I don't know how any of the other companies are going to do this because in order to be able to get that brain, you need it to be an AI software company. You know,
Mhm.
First and foremost, you need to have a supercomputer. You need to have neural networks, and this is OpenAI showing that using just neural nets, the bot is learning, and they just showed the bot the hands of how it's going to manipulate it. The second thing is the dexterity of the fingers. How important is it to have hands and fingers with that ability to do that? You can see that OpenAI thought it was important. Tesla believes it's very important. and then you've got just one or two, but they don't do it because it's very difficult to do bipedal walking. It's very difficult to do fingers. And so many of the other bots we saw today, they forget that stuff. So while they look great, even the Boston Dynamic ones, it can't do these things. And so tell me, how important is it? I mean, clearly the one reason is that it can handle tools. If I needed to grab a drill, it knows how to grab a drill, it'll be able to use a drill. If it needed to use a hammer, it'll be able to use the hammer and hold a nail.
Mhm.
How important is it that it has the brain and then the fingers?
It's very important, and it's not just the dexterity of the fingers, it's also the haptic feedback that's gonna be there. So, Sanctuary is saying that they're putting a lot of sensor technology in there. I'm not sure if the sensor technology is tactile in the sense or if it's really just, the ability to feel the strains that are coming from the motors. So we know that's what the TeslaBot is doing, and I suspected Giant AI was doing the same thing with the tendons. 'Cause my feeling is like, wow, what they're doing is like a really, really challenging problem, and you could never solve that with a heuristic. But if you're an AI company and you can
Mhm.
and you model it well, or you get enough iterations in there, maybe you begin to understand exactly what you have to do with all those motors way down here in the belly to get the reaction that you want to have out there in the fingers. So a lot of it comes down to, again, that we've talked about this many times. I go to close my finger, I'm expecting it's going to require this much force, and as soon as I come into an impediment, I feel that and say, aha, that's there. So sensory feedback is very important, and connecting that to the eyes. So the first thing, when I see what it is I'm going to grab, I label it. And
Mhm.
remember, that's what agility was saying, is that it's labeling these objects, it's looking at them and saying, oh, I kind of know what that is. I kind of know what it takes to pick that thing up. And so it goes over there and is looking at that with the expectation of knowing it's going to require this much force. And if what it discovers is a little bit different than what it's expected, it will kind of react and try to figure out what that is. So we've learned with everything in our environment that we're like 99% sure it's going to be a certain thing. And so most of the time it is exactly that. So we have no problem picking it up. But then when we get something and if it turns out this is like, you know, actually made out of paper and not plastic, and it's like some sort of trick shot joke thing that someone put here to try to trick dad, to come over and I'm going to pick it, then I'm going to be kind of shocked. Oh, what is that? And then I'll quickly adapt to it. Now the AI might freeze and say, that's not what I'm expecting. And then it says, I need some help. And then the tele operator will come and say, okay, what's the problem? Say, oh, that's not what you're expecting. So we'll go ahead and we'll sort of show you what that is, and we'll put that in the training data set. So it is very important for you to be able to understand its environment, to already sort of have a good guess in its head what it expects is going to happen. And then when it goes and then it happens, if it's very different than what it expects, it stops. But it's going to expect a little bit of variation. That's the whole idea. The world's not exactly the way you expect it, and it will adapt to that very quickly. So the brains are very, very important. Sensory feedback is very important. And again, coupling it with eyes is extremely important so that you sort of see what's going on, what your expectations are. And maybe from that, you can begin to understand by looking at it, you might get an idea, well, what is the problem I'm having here? If I look at it, maybe I'll get a sense of what the issue is. I'll see that, oh, my hand's not moving, and maybe you realize, oh, I'm snagged on something. You'll see that, and then you'll make the connection of like, oh, how about that? There's some rough surface here which is snagged me on here. It's good to know about that. Next time I'll watch out for that.
Yeah. So just some final thoughts. It strikes me that that first of all, the convergence of the technology, it's exciting. This is it.
Mhm.
Robots are real. It's going to be here.
Yes.
Um, yeah, but the question is, what we saw a variety of bot videos. It could just be demos, and they made it look good. Like the Asimo looks great, but we know for sure that that is really not. That was a lot of fancy coding and so forth, and it really wasn't useful. But then, if some of them are real, like when we're seeing a demo, it's actually able to do this, and we're at
Yes.
the right timing. And then the question is, who's going to have the brains? The brains.
It's the brains.
What you said was the way you answered it was, well, no. There's many different use cases. Some cases you don't need a brain; you could program it. Like Digit will have a role in
Mhm.
factories, and it'll find places for it to walk around, grab items, move things around. And it was designed as such, but it was still bipedal, humanoid, but it doesn't have the fingers, but it needs enough to just grab things. Um,
Right.
Tesla's approach is to be basically general humanoid, general purpose humanoid robot. It could do anything. And then they built it so they can mass produce it, and then they've got the brains. So there's going to be other competitors to be able to do their brains, but it's going to be far and few between at this point. Who can actually have the greatest intelligence to then self-learn? Because some of these other things you can teach it by teleoperation, but that's so slow to teach it, and it might be able to do one item or one task. But if you have the brains, it can learn a billion tasks. It can do infinity
Yes.
tasks. It might even just learn it on its own.
Yeah. Yes. Yeah, eventually, that's what you would hope, is that it starts figuring out. You get this emergent technology, this emergent behaviors that you weren't planning to be in there, wasn't in like your training set, and suddenly it's extrapolated a few things and said, "Hey, I can go ahead and do this." And there are a lot of classic examples of these game playing AIs that learned how to cheat and everything else. It's like, well, wait a
Mhm.
minute, that wasn't in there, but it's like that's the emergent behavior. So you may be able to see that from the bots, that they begin to realize, hey, there's a shortcut, or there's some other way to do something, or I combine this idea and that idea together to get something else that you were not expecting. So what you have to remember is that the Tesla philosophy has always been to remove all the parts and processes until you get down to the bare minimum, and then if you don't have enough, to put them back in. So the TeslaBot design, partly because they want to make it cheap and manufacturable, is to simplify it as much as possible. So that's why they have almost the minimum degrees of freedom, whereas you see some of the others are putting in a bit more, because they might be thinking, well, wait a minute, we need that dexterity because we really hope this is going to be used in the home. And to be used in the home, we think we're going to need to have hands which are able to do things like close a zipper or do some folding of laundry. The factory floor, it's like, we don't have to worry about closing zippers unless we are actually in a zipper factory and we need to test these things out. But if we're building cars, that's not an issue in most cases. Maybe in the seating line, you're going to need some dexterity or something like that. But for the most part, it's very, very simple hands. And you could always add more later on. So right now, they're trying to find out what is the lowest level. How far down can we go to get a useful robot? And we know this is not going to be the last version of the Tesla bot. Once they get it out there and going, they're going to learn from it, and then the next version comes out, and the next version, and the hands will get better and better. But in the end, it's really that brain. The mechanical has not been a problem. A lot of the control systems have been mostly solved. Now there's still, and now we're seeing some of these control systems that are able to react really, really quickly. So some of them were a bit slow and clunky, that once you lost your balance, there's nothing you do, you just fell over. Others now can react really quickly. So as soon as they lose their balance, they know exactly what to do. So there has been some improvements in there, but that's separate from brains. That's more or less just getting the reaction time to those a little bit faster, having some better models of the dynamics of your control system so it can do that. But tasks, that's the big thing. And LLMs is going to probably solve that a lot. I think we'll probably see something by the end of the year, some remarkable things that we did not expect of the bot being able to do certain tasks very quickly and very easily, even though it wasn't taught.
Okay. Thank you so much, Scott. So we covered 10 different bots. Scott and I have done many videos now on the Tesla bot. So we didn't cover that in detail because we have already. So go take a look at those videos. I'll put those links in the description. Uh, please follow Scott. He's on Going Ballistic 5. I think that's right, on Twitter. Right,
Yes,
Scott?
on Twitter. Yep. Yep.
Yeah. Follow him there. And thank you again very much. Appreciate this. It's always fun.
Okay.
This is
Yeah.
good.
Thank
Thank you.
you for having me back, Herbert.